Hello and welcome to this course on an introduction to R programming. My name is Valentine and I'll be your instructor. This course will follow the following structure. So we'll get started learning about the learning outcomes. After that, we'll get to learn about what is R, why do we use R. Later, we'll go into an in-depth reading where we go through some curated reading that we've prepared, and this will just give you some more information about those basic concepts about R that we're going to be covering later in a practical way. So you'll go through this reading and also go through this quiz, which will just check your understanding of those particular concepts. Once we have finished that, which should take us about 10 to 15 minutes, you will now undertake the practical experience of this particular course, and this will involve going through the basic concepts in relation to R, and we'll go through those concepts for about an hour or so. In terms of installations, you don't have to worry about any installation. You don't need to have installed any tool for learning R. However, of course, in the long run, we will give you some guides or tips on how you can get started on your machine locally. But yeah, so that should take us about 60 minutes. Then afterwards, we'll talk about the next step, which will involve providing you with some project on that will help you just put into practice what you will have learned in this particular course. And the idea is that you will be in a position to transfer your ability to work with those basic concepts in now a real life project and be able to write R code. The idea is by the end of this particular course, you should be in a good position to be able to leverage the basic R skills that are required whenever it comes to working on just data science projects. So if you want to undertake data analysis with R projects, then having gone through this course should just give you some confidence on how to just write R code as well as read R code, even though yes, of course, you will be required later to learn some advanced concepts in relation to now the use cases that you have, whether it's data analysis or data visualization or even machine learning. Then that you could always be able to pick up later, but it usually comes with ease if you've gone through this particular workshop. So so let's get started with this particular workshop. Starting off, by the end of today, we expected to have achieved these learning outcomes. We should be able to declare variables in order to store data in R. Variables are just temporary containers that we can later onwards manipulate. So for instance, we could read a data set maybe from a CSV file or load a data set from even an Excel file. Once we load it from those files, we would normally store it in some variable container and then later apply some methods like, maybe handle missing values or handle duplicates on that particular container that we have. So one of the most important learning outcomes, being able to declare variables, being able to use the print function in order to display what's stored in variables, being able to use what are called arithmetic operators in order to perform mathematical operations in R, being able to use conditional if statements to make decisions in R. So in cases where you want to perform certain conditions, such as maybe if this particular value exists maybe in a column, then should do something, then conditional if statements will come in really handy. You should be able to determine the data types of different types of data. These are just classifications. You should be able to use for loops to iterate through data in R. So assuming you have a large number of just collection of data, it could be rows, it could be columns. If you want now to go through each and every of those items and apply some operation, then for loops will come in handy. You should be able to use lists, vectors to store and retrieve data in R. So we normally use these, they're called data structures, and they help us be able to just store data, a set of related data or collection of data for just temporary manipulation. So maybe you might want to convert the column names of a data set, and to convert them into lowercase and store them somewhere. Sometimes you might want to pull those names from the table that you have, or the variable that you have, then store those related items in a list or a vector, and then later perform some operation on that list or vector, which would be maybe lowercase the column names. And be able to create functions to write reusable code in R. This is just a way of being able to organize code, code that is readable, code that is efficient. Yeah, so those are the learning outcomes. So by the end of today, you will have been able to cover these learning outcomes. These are also the basic fundamentals when it comes to programming, specifically R, but they usually remain the same across different programming languages. If you go to another programming language like Python, you'd still find some of these, actually almost all of these fundamental concepts. The only difference is that you would implement it using Python, which is another language. So the way you write code when it comes maybe to declaring variables in Python would be different from what you would how you would write code with R. So yeah, so let's get started. So what is R? R majorly is a programming language, and it's an open source as well as also open source software environment that we can be able to use for performing statistical computing and as well as data analysis. And the reason why you might undertake learning R instead of other languages is because of ease of use, as well as its matured ecosystem that provides us with lots of packages. These are just more like what are called libraries in another context, or code that has already been created for performing specific use cases. So within R, the R ecosystem, you will find packages to perform almost any sort of statistical computing operation, and that is one of the strengths of this particular language. So it's usually designed, R is designed majorly for data analysis, statistics, data visualization, as well as data science. A few reasons why we would use R. So it provides, again, as mentioned before, a wide range of statistical techniques for analyzing data. You're able to also perform data manipulation as well as transformation. So if you want to perform identify missing values, or and also handle that particular missing data, you will find that R will have packages that will allow you to be able to do those particular tasks with ease. You can also be able to handle data from various sources and formats. So for instance, if you want to import data from CSV files, if you want to import data from Excel files, then you should be able to find that possible. R also has a vast ecosystem of packages and libraries, so which are quite a large. They're quite a lot. I think if you visit, there's a repository that contains quite a large number of those packages. Just trying to see whether we can be able to preview those particular packages, and let me see, R packages. Just googling that. If you were to just Google R packages and visit this resource available, CRAN packages by name, you find that you'll get to this page, and this will be just a list of packages. So what you'll see will be just a list of R packages, which is just code that has already been written by other data scientists or software engineers or other data professional researchers that allow you to do a specific task. So you might have already a package, which is, again, just a collection of code, or what you'd call functions. And the idea is that instead of you writing code from scratch, let's say, for instance, to perform a task like let's just use the analysis of biological data. If you want to perform analysis of biological data, which might be useful for persons in our researchers in this field, instead of starting from scratch to perform that and to create codes that performs that type of analysis, then you can refer to this particular package. It's called ABD, and then actually even get more information about it. There is even a reference manual that gives you an idea of what this particular package entails, and it also gives you just different aspects about the package that you can you need to know. So for instance, if you want to let's even just have a look at one particular function that might be useful. So if you want maybe to perform to determine maybe the correlation coefficient of sex ratio in bird offspring, then you can use this particular function that has been provided, bird sex ratio, to be able to determine this correlation coefficient, and how you implement it would be as shown. So this, assuming this is you're creating a histogram, inside it you can define bird sex ratio in that particular function. So that's one particular use case of how you can be able to use our packages in order to just perform any sort of task that you want. And again, there are quite a large number of packages as mentioned, so this is usually just up to whatever use case that you might end up having. So in addition to that, I think one of the things that R is quite popular for is data visualization, because you're also able to create publication ready charts as well, graphs, and the idea is that that is usually, it comes with ease. So once you have been able to have gotten an understanding of the basic concepts of R, then when it comes to just creation of such, it also R provides a package that gives you just enables you to just create visualization ready charts, not publication ready charts, as well as graphs. Okay, moving on, in terms of the fundamentals, these are just fundamentals that we're going to be covering. I've already mentioned a few in the learning outcome section. So we'll start learning about variables and getting to learn about what they are, which are just containers, temporary containers that we store data in. Printing, so if you want to display the value of maybe a variable, or even later onwards, as we'll get to see when we are working with some advanced containers such as lists and vectors, which normally we would term as data structures, we can also be able to print out their contents by simply using the print statement or cat function. Actually, not print statement, but print function. Arithmetic operators will allow us to perform arithmetic operations, conditional if statements to be able to perform conditional, to make decisions generally, to write code that helps us be able to make conditions, the data types which are just classifications that we give to data in order to be able to perform certain operations. So you can have some data that maybe numerical data that's stored in the format of maybe character format, which is the data type in R, and you might need to first of all determine the data type for that particular data, and then convert that into maybe numerical data. You have for loops that we can use to be able to iterate through just a collection of data. Lists and vectors to store just multiple pieces of data, as well as functions. So these are just fundamentals. If you understand these fundamentals, then it becomes really easy to work with any sort of package that you'll get to be exposed to later onwards, as well as also being able to shift across different programming languages when it comes to analysis. So if you maybe want to shift maybe to Python, then you'll just learn about just the basic concepts, which are usually these ones, and the only thing that would be different would just be implementation, and also maybe just one or two specific packages that may not necessarily be suitable in that regard. So may not be necessarily applicable in that ecosystem. Something like vectors, it's not what we normally work with initially as a data structure in Python, but for lists, you'll find lists in Python. All right, so moving on. So now we'll go into our practice work, and our practice work will actually, not even our practice work, we'll go into our reading and quiz. So I've already talked about those different concepts that we're going to be covering, which are as shown. So the idea is that you need to go through this particular document for about 15 minutes, 10 to 15 minutes, which will give you an in-depth perspective of the basic concepts that we're going to be covering. Once you've finished, then you come back, and then we'll so once you've gone through the reading, go through the quiz as well. Then once you've finished, come back, and then we'll continue from there and continue working on the practice aspects of this workshop. So see you in a few. All right, so once you've finished, the next thing that we're going to do is to now go through the practice work. For this particular workshop, in order to work, or this course, in order to work with R, we are going to be using a cloud solution. And normally when it comes to working with a tool like the programming language, that's R, we would be required to install R in our machines, as well as also install what is called RStudio, which is just a program that allows us to be able to write our code and organize our projects. However, you can still continue doing that. The only issue is that sometimes you can get to come across just some few errors, and that might take a bit of some time. But for ease of learning, we will just use the cloud solution, but which will just have RStudio, that software, on the cloud or in the cloud, and it will just help you quickly get started. But again, you can always explore the option of installing RStudio locally, which will just ensure that you don't have the limitations that you might face while you're working with RStudio when it's on the cloud. So just to start us off, in order to now work with RStudio in the cloud, you need to go to posit.cloud. Just click on posit.cloud, and you should get to this particular page. And you need to create an account in order to now be able to have RStudio running on the cloud. So you can create an account, or if you do have an account, or you can always just log in. So once you've created an account, just click on get started to be able to start it. Just choose the free option. We don't need all these ones. Just choose the free options. And just click on learn now, sign up, and it should take you to the sign up page. Once you have gotten to the sign up page and signed in, you should have now your once you've signed in, you should get to your workspace content area. So this is where you should get to. So you can pause the video and do that first, create an account, and then once you've been able to log in, you can be able to get to this page. I normally use just Google the workspace solution for such. But yeah, but generally once you get here, you need to once you've gotten here, go to, let me just zoom in a bit, go to new project, top right, then create a new RStudio project. So click on new project, then new RStudio project, click on it once, and then you should be able to log. So sometimes it can take a bit of some time, but once you've clicked on that, you'll see what you're seeing on your screen. While it deploys your project, at the very top, you can rename it the way you want. For this, we'll just rename it to Introduction to R. So we can double click there, then say Introduction to R programming. I'm just doing this so that I'm able to just save my project correctly. And yeah, so what would be loaded on your screen will actually be an instance or copy of RStudio, which you could also install it locally. So you have different panes or just windows within this particular environment. You have a console, terminal, background jobs window. You have environment, history, connections, tutorial window, as well as files, plot, packages window. And there's also another one that will show up, which will be just an editor window, or you can call them panes if you want. So in order to get started, so once you've gotten here, the next thing that we need to do is to import our file, our practice file, or practice workbook, which will contain just content in relation to what we are meant to be covering. So how to be able to do that is you need to go to the bottom right. This is the file section, and click on upload, and then upload the practice resource that we have already shared. It could be the sample, but we are working on the practice one, so you can just click on the practice one from the Afterwork website and download that particular practice resource. And the download, when you click on that, when you download it, you might even get to this particular page. In order to download it, just download it, and it's going to download. Once it does that, which it will, you need now to go to upload. Then you need to upload that file here, and let me just choose the file to upload. Where is it? Here is workbook. I'll say okay, and it should upload here, which you can see. And then once that is done, you can just click on that file. You can follow that process. Pause the video and just go through that process, clicking on upload, then uploading that file, practice file. And once you've uploaded it and clicked on the file, it should display now the editor window that we can now be able to work with in order to just work with R. You can minimize the console, terminal, background jobs window by clicking on this icon, minimize icon. Once you've done that, the next thing that we need to do is just to install this package that is being asked, R Markdown. So install it by clicking on that. You'll see what's happening behind the scenes in the backgrounds job tabs. You may not necessarily, gives you just what's happening and details about what's happening behind the scenes. It may not necessarily interest you that much, so you can always just even you just minimize it again. So once you have done that, now getting started with RStudio. So what you're going to be seeing here is the editor, and this is where we are going to be able to just write our R code, organize our documents. In R, there are two types of files, common files that you can get to work with. There's usually the .rmd, .r markdown file, which is what we have. There's also .r file that you can also use. But again, you can later onwards convert whatever work that you have into maybe a different format, maybe a PDF, Word document, or even HTML document. Yeah, so if you want. On the right hand side, top right, the environment tab, this is where if we save if we create containers or variables, the values of those containers will be stored. You'll be able to see them in this particular environment section. Over here, the very bottom, this is just a display of our file system. So if we want to organize our project, we can be able to do that from here. Or alternatively, we can also use the terminal tab to be able to write in some code, some commands, some Linux commands that will allow us to be able to see what's happening. Let's say, for instance, if I say ls, I should be able to see all these contents, or actually project and practice workbook here. The .r history is a hidden file. So yeah, so that's just something that just should give you a good idea. These other tabs are a bit self-explanatory. So yeah, so once we get here, we can just see we're on the source area, so we can be able to see just different R code. R code is just what has been enclosed in these delimiter characters, the 3 of them, and this is the first set of delimiter characters here. So there's that, and also once you have done that, once you click on visual, then you can be able to just also switch to not only the source code, you can switch to now a much more clearer mode of this particular notebook. But you'll be prompted to use visual mode, which you can, which is okay, and this is what you see. To just expand a bit more of this space, you can just pull it to the right a bit, and then you can now start working on now R. So maybe going through a few concepts, so we'll get started. This document will contain examples as well as challenges. Not only that, I'll also ask you to, you'll also be required to import the other file. So the solution file, there's a solution file to those challenges. So you can also go through the same process of just simply downloading the actual solution workbook, which you can do that by simply going to upload, then choose the file that you want, then you just choose the solution workbook, and then upload it. Once you uploaded it, so once you've uploaded it, it should also show up over here, which you can see. I can click on it and it's going to open a new tab within this area, and I can also use visual mode for that, to be able to have that solution workbook, which will have just the challenges, solutions, the solutions to the challenges that we have, as you can see. But you know, let me go to the first tab, the practice workbook, and then we can get started. Starting off with the practice work. So what is a variable? So a variable is just, again, a temporary container that we can use to hold any value, and then later onwards we can be able to do some tasks to those particular values. So for instance, if we wanted to create we wanted to work with the value 10, but again, maybe manipulate it later, maybe use that value with another value, then we can be able to use a variable as shown. So in our case, for example, we could create a value. So let me even just zoom in slightly. Okay, I think this is slightly better. Is it? Let me just zoom in a bit. I think this is slightly okay. I can even zoom in a bit more. Just a bit more, 150. Okay, this is okay. So what we have here, this is a comment which won't be executed by our this is also a comment, and so yeah, so what we have here is just the code that we have here. Anything in front of the hash is just a comment, and we won't, it's not code. But yeah, what's here is what will be executed. So to create a variable that we're going to work with, let's say variable a, with a value 10, we can use this particular a character, or to be able to represent that. So 10, the value 10, we assign it. We use it's usually called the left assignment operator, and we store 10 inside a, then we print a, or we can just print a as shown here. Just fixing that, those small spelling mistakes. But yeah, to run this particular cell, this particular chunk, we called it a chunk or code section, but we just in R we just call it a code chunk, or just a code chunk, which is just a section of code. We can click on this icon over here, run current chunk, and you can see that we printed a here, which is what has been printed here. Then we print a here, which is what has been printed here. What's our interest is what is here. All right. So that's how we can be able to print or to store a variable, to store a value inside a container. So we created a variable called a and assigned it with a value 10. Moving on, if we want also to now perform some operations on that variable, so right now we have created a variable and then printed it using the print function. If we want to now perform some operation on that variable, we can use now what are called arithmetic operators. So let's create another variable called c, which is what you see here. We used a left assignment operator. It's less than dash. It's more like an equal sign, like c is equal to 5, but now in R we use a left assignment operator as shown. And then we can perform an addition operation. So use a print function to display what's a plus c. A will be just 10. So what's a plus c? That's 15. A times c, 10 times 5, that's 50. 10 divided by 5, that's 2. Then 10 minus 5, that's 5. So if we run this, we should be able to get the outcomes of that. So click on here, we should be able to get 15, 50, 2, and 5. If also we want to perform an operation that's called incrementing a variable by 1, so we can use what is called an increment operator. This is usually quite popular when it comes to programming generally, where you can be able to increment the value of a variable by 1. This may be when you want to go through a list or collection of items, so you could always just increase by 1 in order to go to the next item. So this is usually an important operation, and to be able to do that, we usually we write a plus plus, or the variable name plus plus, which is more equal to, let's say for instance, it's more like we put a comment there, it's more like writing a is equals to a plus 1. So the current value of a plus 1, then we replace now the a, then which is the variable that we have, with now this particular operation. So if I run this, I should be able to get a initially was 10, so I should be able to get 11. Oh no, not 11, 20. Actually, it's 20. The reason would be because just a minute, let me see. So I think this increment, we don't have an increment operator actually. So I think to achieve that operation that I mentioned to you, you'd actually need to write the code as shown. So that's probably how you would need to do that particular operation, where you have a equal to a plus 1 is particular shown. So if you click on this, if you rerun this, you always go to the next. You'll actually add 1 plus 1 to the value of a. All right, so I think that's it. Now just work on the challenges for the first section. Then once you're done, just verify them, verify your solutions with what you have here, and then once you're done, we can continue. All right, moving on. So the next thing that we're going to go to is now data types, and these are just classifications that we assign to just data. It could be the data that's stored in a variable, and we can be able to work with these data types in order, maybe before even performing mathematical operations. Sometimes data can be stored in the form of maybe a string data type or character data type. Like as you can see here, we have data that is in a string format, or character format. So in that regard, we would need to convert that data to the right format, the suitable format, which would be integer, so that we can be able to perform some mathematical operation on that data. So starting off, to just be able to identify a data type for the data that we are working, we usually use the type of function, as you can see here. And something that you might note is that we have a print function, but that print function takes in another function, which is type of a. So let's see what's happening here. We store the value 20 inside the variable a. Then we also store the value this other 20, but now this has a string, is a string in a string format. We store it in A, then we print out the type of A. Same case, we are also printing out the type of A here, which is just identifying the data type. And lastly, we also create this complex number, and we store it inside A, the value A, and then print out the types. So to print out the types, we usually use type of, and let's run that and be able to observe what you see. So we have double. Double is a type, or it's a data type in Python that we can use. It's not necessarily actually an integer, it's just a double. We also have a character data type, not necessarily just a string, but we call it a character data type in R, as well as complex data type here. So for double, we normally it's just the number type of data type format that contains decimals as well. So 20 here has also been classified as that number that potentially contains also decimal, but you could also have integers if you want. For character data type, we just have data that contains text. So, but the idea here is just that you have understood how to identify, again, data types. If we want to, for instance, perform an operation and we haven't performed, we don't have the right data types, we are likely to get an error. For example, in this case, we have created this variable X and this other one Y, and stored the two values again in those containers, and we want to perform some operation. So if I uncomment this and I run this particular chunk, I'll get an error. Error in X and Y, non-numeric argument to binary operator. So it tells us that one of these particular values has a data type that we cannot be able to use with another operator when we are performing some operations such as addition. So we need to convert this into we need to convert this into from a character data type into a double in that regard, or even an integer. So you can even just remove the quotes and then rerun the chunk to be able to get that right. We have done that manually, but we also get to see how to be able to use code to perform that conversion, which is what we are going to do next. So instead of just removing the quotes like we did, we can do something to the value of Y, which is use a function called str2i, string to integer, and we pass the value of the variable, so which is what we have here, and we pass it into string to y. Then we say x 300 plus string to y. The outcome of string to y, we just convert 100 to the numerical equivalent, and voila, we have that. So 400. Moving on, so here we have been able to perform a string to integer. We can also perform string to float. By string to float would be double. So assuming that double is float format where you have decimal places. So for instance, here string to I 10 would be, if we run this, let's just run this and be able to see, we have an integer, string to integer. We have an integer, but again, we have this decimal value, so 5.0. We store it in B. Type of B would be double. A plus B, so the outcome of A plus B, we store it to A, which is now the string, the integer here, sorry, which should be 10 plus 15. And the outcome would actually be a double. So the idea here is that whenever we have the integer, we add an integer to a double, we always get a double as the result. Moving on, so we can also use the addition operator to combine just the values of two strings. So for instance, if we have first name is what you see here, and so this value has been stored inside the first name variable. This value has been stored inside the last name variable. If we want to combine both, we usually use the paste paste command for that. So paste, then first name, comma, last name, and we should be able to combine both of them in one particular string. And you'll have the space taken into account as well. So if you run this, you should be able to see that. Yeah, so the next thing, work on the challenges. Once you've done, verify them. I'm using the solution workbook, and then we can continue from there. All right, so moving on, the next thing that we're going to learn is conditional if statements. And this concept allows us to be able to make decisions while we are actually writing code. So let's see how we can write conditional if statements with R. So starting off, we're going to create these two variables, x and y, declare them. So once we have done that, assuming we wanted to check whether the value of x is greater than y, we would normally first of all use an if keyword, then parentheses. So if keyword, then we define our condition using parentheses. Then inside the parentheses, we have now the condition. So x is less than y. That's what we want to check, if x is less than y. Then in curly braces, we can be able to define what we want to do. So inside the curly braces, this is a curly brace, we can define what we want, so which is print x is less than y. And if we run this, we should be able to see that statement, print x is less than y. Moving on, example 2. We can also decide to have multiple conditions. And this is just one condition. What if x is greater than y and x is equal to y? Like how can we be able to perform that operation? So that's what we're going to see next. So if we want to chain, you can think of this multiple if statements that are related together. We can use the else if keyword. So this is what we would do. So if r is less than s, which we are creating new variables here, r and s. So what we can do here, so we can say if r is less than s, we run this. If r is equal to s, we can be able to print out what we have here. So we write else if, then r is equals to s, which is the next condition, and then voila. So let's run that. R and s are equal. Moving on, we can also, assuming that these are two specific conditions, assuming that we wanted to take into account of something else. By something else is whatever else that we want to evaluate. If it's not r, if it's not r being less than s, or r equal to s, we can decide to have some run some code for whatever other condition that there exists by using the else keyword. So maybe we create these two variables, new variables, b, a and b, and then we can decide to create use the else keyword for that. So if b is greater than a, we print out that. If a is equals to b, we print out this. Else print a is greater than b. Yeah, and that's basically it with regards to else, the conditional if statements. You can work on the challenges and verify your solution. Once you're done, then we'll continue. Moving on, lists. Sometimes we might want to store maybe multiple values, like variables inside, maybe not inside. We can't use the variables because variables just work with they store just one piece of information. So if we wanted to for example, how should I put it, if we wanted to store multiple pieces of information related, especially maybe a list of maybe restaurants in one particular container variable name, we can use what is called a list. And a list is just a data structure. In programming, we call them just data structures, which are just ways of just temporarily storing data and then performing some operation that particular container that we have used. So to create a list, which we can work with to store multiple pieces of information, we can use the list function as shown. So inside it, we pass the values that we want to store, and we separate those values by a comma. So lists, we have all these values that we want to store in that particular list, and this is the name of the list. So yeah, and we print it out below, and we can be able to see this is our list, the first item, second, third, fourth, fifth, and sixth. And we can also perform operations like be able to update a list, delete an element. So items or the pieces of information inside the list, we can call them either as elements or items, and we can be able to perform different operations, whether it's deleting, updating, or even adding an item. So assuming that we wanted to replace an element, or maybe replace or add an element to a list. So here we have how many elements? 1, 2, 3, 4, 5, 6. If we want to add another one, we can define the location. So each element in a list has a location. This is the location 1, 2, 3, 4, 5, 6. In other programming languages usually start from 0, but here we start from 1 in R. So position 1, 2, 3, 4, 5, 6. So in position 7, we want to have another value, so we use the name of the list as shown, then define the position where we want to store a new value or item or element, and then we define the element carnivore. So if I run this, I should be able to see the last element in that list is carnivore. If I want to retrieve values specifically from the list, I can use those positions. Let's say I want to retrieve them first one, I can do the same thing. Then the second value to the third value, I can use the same thing. And the second last value, you can also do the same thing. So if I run this, the first value was CJs. So in our list, we have CJs. Then 2 to 4, 2 to 4, that's actually not 2 to 4. Yeah, actually 2 to 4. So 2 to 4, so it would be Java, Nyamamama, Java, Mama Mama, and Italian. Actually, this selects 2 to 4, Java, Nyamamama, and Italian. If I want to select -2, so -2, where is it? Because for -2, what we selected was the last last two items. Okay, so I think for this one, actually it's supposed to be restaurants -2. So in this case, when we are slicing the restaurants list, what we are actually doing is actually leaving out the second item. So -2 just basically means we leave out the second item from the list. So for example, in our case here, we are selecting all the items, but we are leaving out Java. So we would get CJ's, Nyamamama, and from here, where is it? CJ's, Nyamamama, Italian, Swahili, Kosa, and Carnivore. That's actually this operation. It's actually meant to perform that task for leaving out. So yeah, so this is different from other implementations in other languages. So just something to note here as well. All right, so moving on to the challenges. Work on these challenges. Once you have done that, just to verify the solutions by simply going through the solutions that you've got in there. All right, after that, the next thing that we're going to go through is vectors, and the vector is just a basic data structure, more like a list, but only that in a vector you have the same type. So here you have strings, or you could have just numbers, as opposed to in a list you can have different. You can have lists, you can have numbers, you can also have strings, etc. So to create a basic data structure vector, to create a vector, we use the C function, as you can see here, and inside it we pass the elements that we want, or the items that we want, which are the ones that we are here. Then we store them in this variable. You can run that to be able to preview. Let's run it. Sorry. Oops. Let me refresh this page. If you get an error such as what I'm getting, a solution will just be to refresh the page, and that should resolve the issue. So once you have refreshed the page, then you should have everything as before. So let's run vectors, and you should be able to see now. First example in vectors have this as the output. So we have this footballers vector, which has these elements or items, and yeah. So let's see how we can be able to select just elements from a vector. You can run that, and you can see that if you wanted to select, you're still using the positions bit. If you wanted to select the first, the second and third element, we can define that by simply still referencing the vector name, then square brackets, then we define the vector positions inside the C function, as you can see here. So second and third is Alexander and Origi. Second one would be Alexander, which you see here. Then we can still again do the same thing. This is the first approach. We can also do the same thing as shown, Alexander. We can even just also say want to select, let's say we wanted to select the first element, that's Wayne as well as Alexander, is shown. From Wayne to Alexander, we can select from Wayne to Salah by simply defining the approach here. And thirdly is footballers. Could also do the same. The last one, we can select all the elements aside from Origi, because it's the one on the third position. So yeah, so that's how you can be able to select vectors or elements from a vector. That's basically what you would need to learn for now in terms of the fundamentals. Moving on, so you can just work on the challenges and then verify your solution. Moving on, the next thing that you might want to, we will actually go through, is for loops and if statements. And a for loop generally would allow us to iterate through some data. It could be lists, it could be a vector, it could also be just some variable, the different characters within a variable. Now, the next thing that we are going to be learning is for loops and if statements, and how we can be able to use them all together. But just to start off, a for loop is just a way of iterating or going through, as mentioned earlier. And yeah, so getting started, for loop. So in order to write a for loop, use the for keyword. Then much more like how you use an if statement, the only thing that we would need to do is use a for keyword, and then inside the parentheses that come after, we would define the variable, that's the container that would contain the current item, the one that we are in during that iteration. We can iterate through many of them, so it can be the current iteration. So variable to store maybe the first restaurant, second restaurant if you're in the second iteration, the third restaurant if you're in the third iteration. So I here can be any sort of variable name, so but we just naming it I. It could be A, it could be current item, etc. So that's what we do there. We write it there in restaurants, and now restaurants, just what are we trying to iterate? What's the collection of data that we're trying to iterate in? So this will just iterate through, go through all the elements in the restaurants, and then inside the parentheses we write code to do what we want to do during each iteration. So you want to print out I, that variable. That's what's going to happen there. In addition, we can also have different loops. Maybe this is for restaurants. We can also do that for another vector. This is a list, the restaurants list. This is now for the fruits vector, which is the one that we have defined here. And we also do something, and we can also use an if statement inside the for loop statement. So that is something. So here we're going to print out all the restaurants as well as the fruits. So restaurants, and then restaurants end here, then fruits start here. Moving on to the second example. For the second example, we can again introduce a for loop inside, an if statement, inside the for loop. So here we are iterating through the mobile phones list, and then we are using an if statement. So x equal to iPhone 8. So during each iteration, we are going to be checking if x, which is the current item, will equal to iPhone 8. So we'll go through the first iteration, iPhone 4. And if it's not equal to iPhone 8, we print out the actual current item, that's iPhone 4. The same case until we get to iPhone 8. And when we get to iPhone 8, we'll break. Break means just we stop there. Like we break out of this loop completely. But we can also use, if you want to continue iterating but skip, let's say, iPhone 8, or just continue, just iterating, you can use a continue statement. But for now, we just want to stop our loop from running. So we will print out iPhone 4, 5, 6, 7, but we won't print out any other element afterwards. So let's run that. Should be able to see that. All right, work on the challenges and verify your solutions, and we'll continue. So moving on to the last section, that's functions. So when it comes to organizing code, we can create what are called functions, and we can be able to use those functions later. So you can write a bunch of code, or just code, and then enclose it in a function, and then anytime you want to use that code, you just call that function. And this is just for ease of ensuring that you don't write a lot of code. You have reusable code and manageable just code. So let's just see how we can create a function. So assuming that we had code, this is the code that we had that performs this particular operation. We store the value 10 in A, the value 5 in B, then we do some conditional if statement. So we check whether A is greater than B and return A, and then if A is greater than B, we return A, else we return B. So this is the code that we want to be using every now and then. So what we can do is to contain this code inside a function. So we start out by naming the function, which is max of 2. Then we use the function keyword, parentheses, and curly brace to just enclose the code that we want to run. So this is a max of 2 function, and to call it, we just call it max of 2 with the parentheses as shown. But we can also give a function an input and it's going to give us an output. But for here, we are giving it we are not giving it an input. We're just getting an output from that particular function. So let's run this, and we should be able to get 10, because 10 over here is actually greater than B, and it's what's being returned. Alternatively, if you want to give a function some inputs, we can give it as shown. So here we have average of 2 numbers, which is the function that we have, and we have it here. But now inside this function, we have this code that we want to run. So this particular code will have a variable where we assign the outcome of this operation x plus y divide by 2. X plus y will be the input that we will give. So we have set of inputs, 2 of them, x and y, which in this context we call them as parameters. So as average of 2 numbers, we give we can pass now any sort of inputs that we want to the function by calling it here. So we have 2 and 2, which 2 will represent x and the other 2 will represent y. They'll be taken inside, and the operation will be done. So 2 plus 2 would be 4 divided by 2. That's 2. And what will be returned would be 2. So the output is 2, as you can see here. All right, work on the challenges. And when you're done, then we can continue to the next steps. All right, so once you have finished working on the challenges and verified your solutions using the solution workbook, the next thing that we're going to need to do is now to go through the project, which we have shared already. And the idea is that you're going to apply the skills that you have used or you have learned so far in order to put into practice in a real world, put them into practice in a real world setup or setting. So in this project, you'll be required to create some code, R code, that allows you to perform the mentioned task. Once you have done that, you can also verify your solution with now the solution that we had also shared. This is a sample solution. You can download it and upload it again to pause it to be able to just see how you could have alternatively gone about the solution. And that's basically it. That would be basically what you'll be required to have done for this particular workshop. And the next thing, once you've done that, the next thing in terms of the course that you can undertake now would be working on data wrangling with R, or data analysis with R. And the idea is that you're now going to be feeling confident enough to now work with data sets and be able to solve for data analysis projects. All right, that's it. I hope you're able to learn the fundamentals of R, and you're ready to now continue this journey. Just to ensure that you use the resources that we've provided to the very best. And once you're done, let's continue with this learning journey and see you in the next course. All the best in your learning.